Hi Chem Peeps, this is video 2 using the electron configurations in the periodic table. You can see the image I have here shows the different sections where we can find the different clouds that the electrons fill. What's really cool is this aligns with the diagonal rule too. So you can see that the first two columns here represent the S cloud. The last 6 columns over here represent the P cloud. Now, of course, helium only has 2 electrons, and actually that one belongs over here, but we place it over here in column 18 because it behaves just like the noble gases, and this whole column here below it are the noble gases. But this section here is the P cloud. Then the middle section here, we have the D cloud, and then finally the two bottom rows are the F clouds. Now, let's talk a little more about the details of what we're seeing here. I'm going to just make this a little bit smaller so that we can see better what we're doing. So, the S, we know, can hold 2 electrons. Notice that there are 2 columns. The P can hold 6 electrons, and if we count across here, there are 6 columns. The D can hold 10 electrons, and if we count across here, there are 10 columns. And the F can hold 14 electrons, and if we count across here, there are 14 columns. I also talked on the last video that we have rows on the periodic table, and there are currently 7 rows. And those, oops, this must be 5. The 7 rows correspond to energy levels. And if you remember from my first video, I told you that electrons fill energy levels and clouds by lowest energy to highest energy, and that's why on the diagonal rule and when you write electron configurations, we don't go in chronological order, we go from lowest to highest energy. And so when we're writing configurations, we might be at 3s2, then 3p6, then we go to 4s2, then we go to 3d10, and then back to 4p6. And we question, well, why don't we just fill all the 3s at first and then go to the 4s? Because electrons fill from lowest to highest energy. So in the last video, we did zinc with 30 electrons. And we filled up the configuration by following the diagonal rule. But if I follow the periodic table, I'm going to start and follow my atomic number. So atomic number 1 is found right here, and then 2 is the helium, and then we're just going to keep following across here until we get to zinc here. And when we follow the periodic table, we're going to first fill 1s2. Then we're going to fill, and that counted this one over here. Then we're going to fill the second row, which is going to be 2s2 and 2p6. So I went the whole way across here. Then I'm going to fill the 3s2, and then if I go across, notice that the transition metals, or the D cloud, do not start in the 3rd row. So I'm going to fill 3d10, and then I'm going to go to the 4th row, and it's going to have 3 things here. It's going to have 4s2, then it's going to have, oops, I made a mistake there, didn't I? And I didn't catch it. I was thinking ahead of my brain. All right, so 3p6, then 4s2, then we fill the 3d10, and then after the 3d10 comes the 4p6. And so I'm just going to follow these. Now, when we get down here, it's really important that you look at the atomic numbers, because the barium that is found right here, it has an atomic number of 56. The next element right beside it, the Lu, has an atomic number of 71. So there is a gap here, and that gap is right here. The 4F comes after the 6S. And so if you look at the atomic numbers here, it runs from 57 through 70. So when we're filling the 6th row, we need to know After the 6s, we go down to the 4f and then back up to the 5d. Well, how does the next row, the 7th row, work? Well, if we look at the atomic numbers, radium is 88 right here, 88. And then the one right next to it, the LR, is 103. So again, there is a gap here. That gap, so after the 7s, we have to go down here to the 5f and fill from 89 through 102. And then we come back up and keep going in that 7th row. So the diagonal rule does correspond to this, but it does become easier to do electron configurations so that I'm just using the periodic table. So let's just do a couple examples. So I'm just going to pick a couple elements off the periodic table. I'm going to pick chlorine, which is found right here. It has 17 for its atomic number. I'm going to fill the electron clouds and energy levels until I get to that 17. So I'm going to come across row 1, so that's going to be 1s2. Then I'm going to come across row 2, which is going to be 2s2 and 2p6. Apologize for that messiness. Then I'm going to come across the 3s row, or the third row, 3s and 3p. I'm not going to quite fill it completely because chlorine is found in column 17, and so it's going to be 3s2, and yes, the p can hold 6, but I only need 5, so I'm going to stop there at 5. So if I count up these numbers here, that's going to equal the atomic number, or 17 electrons for chlorine. Let's look at one more example. Let's pick one that maybe goes out of sync as far as chronological order. Let's pick hafnium, which is 72. And 72 is going to be right here. Okay, so I'm dealing with HF. Okay, so I'm going to go and start filling up the electron configuration. I'm going to go through row 1 first. So I'm going to have 1s2, and then I'm going to go to row 2, 2s2, 2p6, then the third row, 3s2, 3p6, fourth row, 4s2, 3d10, 4p6, then the fifth row, it's going to be 5s2, and then 4d10, then 5p6. Now I'm here in the 6th row. Remember what I said, in the 6th row, barium, which is found right here, is element 56. And then I'm going to have to jump down here to the 4F, complete it, and then come back. So I'm going to fill the 6S, and then I'm going to go down to the bottom and fill the 4F, and they can hold 14. This S needs to be better. And then when I come back up here, I'm going to fill 2 more electrons in here. I'm going to fill 5D2. And if I add up these superscripts, they should add up to 72. And that is how we do the periodic table for electron configurations. I tell my students, if you learn the arrangement of everything in the periodic table, you can quickly figure out where you should land. So hafnium was right here. It was in the 2nd block. That would be 5D2 should be the last configuration I wrote. When we did chlorine, it's found here. The last thing I should have written was 3P5 because I can count over all the blocks here. And I don't know if I can do this. 1, 2, 3, 4, 5, 6. So chlorine is in the 5th block. Hafnium is in the 2nd block of the D. And so that's how you can use the periodic table to quickly see how far you have to fill the electron configuration up. We're going to talk about how to make this shorter. This is a really long one, and there is a shortcut that we can do, and I will do that in my next video. So you can find me on Kim's Chem Chat on TikTok and YouTube, and I will talk to you later.